morning, my dear students. Today I am going to start fifth unit. So in the fifth unit, let us discuss the first half part of fifth unit, that is realization of digital filters, and in the second half part we have the finite wall length effects. So in the first half part of fifth unit, the first topic, that is applications of jet transform. So let us discuss about applications of jet transform. This one, applications of jet transform. I'm going to put side heading applications of jet transform. As we know that jet transform is a powerful mathematical tool which is used in various fields, like digital signal processing and digital image processing and control system and communication system. These are the key applications of jet transform. So as a topic we have applications of jet transform. Let us discuss thoroughly about the applications of jet transform, how the jet transform is used in digital signal processing and communication system and control system, as well as the digital image processing. First of all, I am going to write down the key applications of jet transform, or the real life applications of jet transform. The first one is digital signal processing. And control systems. And communication systems. In the communication system also we are going to use a jet transform communication system. These all are the real life applications of jet transform communication system and digital image processing. These are the major applications of jet transform: digital image processing. Okay, I will show you how these jet transforms used in digital signal processing and control systems and communication system, digital image processing. In order to explain these applications of jet transform, I have prepared one presentation. Through presentation I will explain thoroughly. For that I am going to open this one is a slide. So in this presentation I am going to explain. The first one is a real life application of the jet transform. So see here, the jet transform is a powerful mathematical tool widely used in various fields, particularly in signal processing, control system and communication. So the first application is a digital signal processing. In the digital signal processing, for the purpose of filter designing and audio processing, we are going to use this jet transform. See, so the jet transform is used to design a digital filters, example FIR and IIR. As we know that FIR filters and IIR filters are the digital filters. And coming to the analog filters, that is Chebyshev, Butterworth approximation. These all comes under the category of analog filter. That is, to analyze the digital filters, to analyze the digital filters, we are going to use a jet transform. So it is the first application of jet transform. In the first one, filter design, that is designing the digital filters for signal processing. We know that processing is performing some operations on a signal. Performing some operations means either it may be addition, subtraction, or the multiplication, or the shifting, whatever the operations. Okay. Next, coming to the second one, audio processing. Audio processing means to simplify the audio signal, or to process the audio signal, we are going to use a jet transform, that is analyzing and processing audio signals. And the second application is control system. In the control system, especially for the discrete time control and the stability analysis, we are going to use this jet transform. In the discrete time control, in model control system, especially in robotics and automation, and jet transform is used model and analyze that operate in a discrete time. And the second one, stability analysis. Engineers use the jet transform to assess the stability of the digital control system. In order to assess the stability of the digital control system, we are going to use a jet transform. Let us see jet transform in control system. In the first one, that is a model discrete time system, use a jet transform to represent a system operating in discrete time. That means here the main intention, or the main thing, or the main advantage of jet transform is, in order to represent a discrete time system in a frequency domain, we are going to apply jet transform. That is, after applying jet transform to the discrete time signal, which is represented in frequency domain, that is to convert a discrete time system. What type of discrete time system? It is a linear discrete time system. Okay. And the second one is an analyze system, a linear time invariant discrete time system. In order to represent a linear time invariant discrete time signal in a frequency domain, we are going to use a jet transform. And the second step, analyze system stability. So analyze the system stability, that is evaluate the stability of a digital control system. In order to evaluate the stability of digital control system, we are going to use a jet transform. And the third step, design controllers, that is develop controllers that meet performance criteria. And the fourth step, implement in robotics. In robotics also we are going to use a jet transform. And the third application of jet transform, that is a telecommunications. In the telecommunication, for the purpose of signal encoding and error detection and correction, we are going to use a jet transform. In the first one, that is a signal encoding. As we know that encoding is a process which is used to reduce the bandwidth of the signal, the main intention. Okay. So the next, error detection and correction, especially in digital communication system also, in order to save the bandwidth, we are going to perform an encoding before transmitting the signal towards the receiver side, and after receiving that information, again we are going to add the bits. As we know that which is called, that process is called as a decoding. Decoding is a process that is performed at the receiver side. Encoding is a process that is performed at the transmitter side before transmitting the signal. And the second one, that is error detection and correction. So we know that in a communication system, the main elements of communication system are mainly three. In addition to that, we are going to consider one more thing, that is, in practical cases, there is a presence of noise while transmitting that signal from transmitter to the receiver. The basic elements of communication system is a transmitter, receiver, and in between these transmitter and receiver, there is a presence of channel. That is, the basic elements of communication system is transmitter, channel, and receiver. So while transmitting this signal or the information from transmitter to the receiver, some unwanted signal may interfere with that information or the signal. The interference of this unwanted signal to the information or the signal is called as a noise. Okay, so that is after receiving the information, we will get the noisy information. To remove that noise while sending the digital data through a channel, due to presence of noise, either it may be a internal noise or external noise, due to the burst errors also, the data bits may change. So how many number of error bits are present in information, that is error detection, and how we are going to change that is error correction. After correcting that errors only, we will get the original information, whatever the information is transmitted by the transmitter. So this one, jet transform in digital communication, it is a signal encoding. At the receiver side, we are going to perform these two, error detection and error correction. No doubt, while transmitting the information through a channel, error may present in the data or the signal. Image processing. As we know that processing means performing some operations on signal. Here image processing means performing some operations on image. That is image filtering. That is similar to audio processing. The jet transform can be applied to process the digital images, including filtering and enhancement. Mainly in image processing, we are going to use filters to get lower details. That is in order to blur the image, and in order to sharpen the image, we are going to use high pass filters. In order to blur the image, we are going to use low pass filters. And coming to the compression algorithms, that is, as we know that every image is stored defaultly in terms of JPG, where the JPG is Joint Photographic Expert Group, which is also called as JPG. As we have seen, that is, if we will take one snap with the help of our mobile phone, in that mobile phone, that image is stored with the extension of .jpg. That is, that JPG is a compression standard. But because instead of storing the same value on multiple pixels, here either by reducing the pixels or by reducing the number of bits required to store a gray level value, we are going to perform compression. Okay, that is techniques like JPG compression utilize the transform, including the jet transform, to reduce image file sizes while preserving quality. And this one is a pictorial representation, that is the jet transform in image processing. That is, apply jet transform and apply filter image, and after applying the filter image, we are going to perform the compress. So after compressing only, we are going to store that image. Why? Because if suppose without performing any image compression, if we will store that image at that time, that image requires more amount of memory, or the large size of memory to store a single image. For that reason, we are going to perform the compression. After performing compression only, we are going to store those images. Defaultly, whatever the systems nowadays we are using, the gadgets, electronic gadgets, all these electronic gadgets as the systems are defaultly perform the compression. After compression only, those images are stored. That is the reason any image based on the pixel quality, for example, let us use 1 megapixel camera. So if we will use 1 megapixel camera while taking the snaps, that 1 megapixel camera captures the very less amount of details compared to the 10 megapixel camera. That means at 1 megapixel camera, whatever the image is captured by the 1 megapixel camera, that image requires less amount of memory size in order to store that image onto memory. If you will use a 10 megapixel camera, that 10 megapixel camera captures more details, so it requires more memory size. That is depending upon the pixel size also, the memory requirement depends. Next, financial engineering, that is the time series analysis and risk management. Also, we are going to use a jet transform. That is, the jet transform can be applied, analyze the financial time series data, helping at forecasting and modeling stock prices or economic unit. This one is related to the management, the managerial economics. Already we have an idea on BEFA. So in the BEFA, to analyze a stock, how much of stock or predictions of the stock or the demand. So for that we are going to use a jet transform. A transform is nothing but changing. And second one is the risk management. That is, it aids in the development of algorithm for assessing risk and optimizing investment portfolios. So it is a cycle of jet transform in finance. That is, analyze time series data and forecast financial trends and develop risk algorithm and optimize investment portfolios. Coming to the computer graphics, animation and motion analysis, the jet transform can be used in the analysis of motion and rendering techniques in computer graphics. So I think you got one doubt, sir. As a electronics engineers, we have some idea on jet transform. Actually, this jet transform, you have an idea on this jet transform in your mathematical point of view. Also, you have an idea like Laplace transform, jet transform, like that. This jet transform is not only for the electron students. The jet transform is applicable for all. So jet transform in animation and motion analysis, that is, analyze motion and rendering techniques and enhance animation and refine analysis. So we are going to use a jet transform. So I will send this presentation to you. And the last application of a jet transform, that is robotics. That is, in the robotics, for the path planning and navigation, a jet transform is useful for us. That is, in robotics, the jet transform helps in the implementation of algorithms for path planning and navigation in the discrete environments. So these all are the real life applications of jet transform, and this one is a pictorial representation of jet transform in robotics. A jet transform in robotics and for the purpose of path planning and navigation. Okay, in the next session we are going to discuss, that means let us recall whatever we have studied in our signals and system subject. Definition of jet transform, how we are going to represent the jet transform, and ROC, region of convergence of jet transform, and the system function of jet transform. Why? Because in our syllabus we have those topics. See, let us see those topics. So in the first one is applications of jet transform. Here the reason we have the application of jet transform as a first topic, that means already we have studied about this jet transform in signals and system. That is the reason here. First we have the application of jet transform, and the second one is solution of difference equation of digital filters. So that is how we are going to find out the jet transform from the differential equation. And the next system function, we know that other name of system function is the transfer function, and the stability criteria, whether the given system is stable or not after applying jet transform. And the next frequency response of stable system. Let us discuss in the next session about solution of difference equation of differential digital filters, solution of difference equation of digital filters. Before going to that, we should recall what is meant by jet transform and how we are going to represent jet transform. And next, what are the properties of jet transform. Mainly in the jet transform we have the two types of sequences, that is the right hand sequence and left hand sequence. By combining those two, we will get a mixed sequence. So based on the given sequence of the difference equation, we will get the different solutions. Okay, we will discuss later about the jet transform definition and the representation of jet transform, and what is meant by ROC and what are the properties of ROC. After completion of that, we will discuss the problems on jet transform. Thank you.